All right, let's go ahead and get started. Thank you all for being here. I hope this finds you all healthy and well in this time, and I hope you've been enjoying our conference so far. Today's the second day of OV's first virtual conference. We've had sessions about all kinds of survey topics over the last day and a half, and we still have a couple to go. So appreciate you joining us for this. This session today is called AI and HR Analytics, the present, the possibilities, and the pitfalls. We've been doing a couple of webinars about artificial intelligence, and we cover a broad range of topics on AI. Today's going to be specifically focused on potential pitfalls to avoid in the nuances of AI and diversity and inclusion. So we'll be getting really nuanced into that topic, but I do want to say we do have more general overviews and other coverage of the topic. If it's something you're interested in, please do let us know, and we'd be happy to connect with you on that information. As far as today, before we dive in too much, I want to cover a couple of housekeeping things. The first thing is the slides. We will be following up with everyone who's attending today with slides and recordings. Those follow-ups will come on Monday, so please don't worry about taking copious notes. Sit back and enjoy and take in the information. Related to the follow-ups, we will also be answering questions as a part of those follow-ups. So our time on the webinar today will be fairly tight. We might not have time to actually answer the questions at the end, but please do type them into the chat box, and we will address those in the follow-ups and get to those right away. Other than that, I would encourage you all to take a look at the next webinars coming up. The one immediately following this one is about framing your survey to get executives excited. And then we'll have GDPR and top-down versus bottom-up survey results. So if any of those sound interesting to you, please do check out our website at orgvitality.com and sign up for any of those. So with all of that started, go ahead and dive in. I'm going to start with a brief introduction here. My name is Victoria Hendrickson. I'm a partner and vice president with OrgVitality on the consulting side. I work primarily in our employee surveys and employee research work, and I have a background and PhD in industrial organizational psychology. So I am here today to talk to you about artificial intelligence. And it's an exciting topic that I have been looking into and researching in different ways for a couple years here. And I think a lot of you on the phone have as well. I see a lot of friendly names or friendly faces on the phone that I've talked to about this subject before. So I know a lot of you are very familiar with this. And so I do want to say in the next 27 minutes or so, again, we're not going to cover all of AI. We're not going to solve for every consideration across this group. So we're not going to try to go broad. Instead, we're going to do the opposite and talk about a very nuanced issue about the use of AI and employee data. We all know that there's enormous capabilities in AI, and we as data nerds look for all of the ways that we can capitalize on these possibilities. But we also want to take a step back and balance that with our responsibilities to the privacy of individual level sensitive data that we're working with when we talk about employee data. So what are we looking at here on the screen? These are all very real headlines that continue to come up. It's easy to find powerful stories about how AI is changing the world, whether it's about you as a person out there as a consumer and the way that your experience is cultivated based on passive data, or whether it's talking about you as an employee or how we as employee researchers are using data. The headlines are that AI is changing the world, and it is. We certainly don't want to downplay that. The possibilities are very exciting, but the danger is that most of us don't know the technicalities on how a lot of it works. And most importantly, when AI and the findings from AI contribute to meaningful decisions. There's a lot that happens in the background that then leads to decisions that affect us in a very powerful way. When I spoke on this topic at Dreamforce a couple of years ago, I asked a room full of people, show of hands, who thinks that AI can make better, more objective decisions than people? And no surprise, everybody raised their hands. Room full of people interested in this topic were very convinced. And then the follow-up question was, all right, that said, who understands how it works? And zero. Actually, zero hands stayed up. I'd expected a few hands to stay up in a data nerd kind of session, but nobody knew how it worked. We have this bias that AI is so smart, it must be objective, but we don't know why we think that's true, and we don't know how that works. So, if we step back, we are in that time where there's a possibility for AI to help us use big data. But it's overwhelming, and we need to be careful how we dive in so that we use it in a very intentional way that expands our reach rather than just replicating our reach. So the goal of the talk today is to look at what AI can do for us, where it's a value-added fit and can help us out, and where there's some pitfalls we want to avoid. So specific to org effectiveness and survey kinds of work that a lot of people on the phone here do, the trends here are pretty clear. Machine learning is front and center throughout data collection and action planning activities. And before we get a lot further, I want to clear up a few definitions. Machine learning and AI are often used as interchangeable terms when there is a little bit of nuance between the two. If we think about artificial intelligence broadly, it's the concept of machines being able to carry out tasks in a way that we would consider quote unquote smart or automated. There are a lot of things that fall into that category. If we take it one step further, machine learning is an application of artificial intelligence based around the idea that we should be able to give a quote unquote machine or algorithm access to data and let it learn for themselves. So more technically, if a program learns patterns from your existing data and then applies that structure to new data, that's machine learning. So an example might be a turnover model where past findings of who quits are applied to current data to predict who might quit. We'll talk later about whether that's a kind of application you want to use, but that's certainly one that's popular and of interest to a lot of executives out there. There's a lot of data on turnover, and certainly if we can predict who might be on the edge, that sounds like a thing we might want to do. So turnover is one example, but there are a lot of opportunities in our kind of work to use machine learning. We see it in action planning. So, how do we help managers prioritize what they want to work on from their data? How do we do that in a smart and data-based way? We also see it in comment analysis, where we identify relationships across huge volumes of unstructured data. And we see it in general big data applications, where we're able to harness disparate data points across different kinds of sources in order to find meaningful relationships across those things that would be harder to do with just a human scale. So all of these potential applications do sound exciting, and it's really easy to get carried away. I was talking to one head of OD who felt he was really under pressure to use machine learning in surveys. Works for a tech company. His CEO came to him and said, well, we make AI, we use AI, we use it with our customers, we've had great success. Why aren't we using it for our people data? The connotation was almost, we're behind if we're not using artificial intelligence on our people data. And that's a really compelling question. It's certainly worth exploring, but there are different considerations when we're talking about employee data. And that takes us to the pitfalls we want to avoid. A moment ago, I mentioned briefly that I spoke on this topic at Dreamforce, and so I want to provide a little more context that ties some of this together. A couple years ago, Salesforce came to us and asked us to speak on this at their user conference. They have a whole lot of cool stuff in this space and in development, but they recognize that with all of these developments in using artificial intelligence on people data do come with risks. So I was talking with one of their designers. He's been in this space a very long time. He's got a ton of experience, but he told me that he's really worried about what's coming and how his work gets used with people data. He said that when machine learning is used with customers, it's really low risk, but high reward. So if they get things right and their algorithm produces good data, they offer a flawless customer experience. If they get it wrong and they make a bad call in designing systems or use bad data, maybe the customer spends a few extra seconds on the website. Not ideal, but it's not a huge loss. Contrast that to using employee data. Of course, there are great upsides if we get it right, and that's why it's worth exploring. But if you get it wrong, you mess with someone's future, whether it's their career opportunities, compensation, or something else. You're intervening on someone's work, their livelihood. And one of the main ways to get it wrong with people data is to use bad data, or more specifically, to use biased data. There are certainly other pitfalls to avoid, but today, again, that focus is going to be on the use of bias in machine learning on people data. And so we're going to look at some of the implications and examples of how we can harness the potential, but avoid that pitfall of depending on biased data. And so if we're talking about bias data, we are going to spend a moment here on bias itself. A lot of you are very experienced psychologists and analysts, so I'm not going to harp on the background too much. But the point is to recognize that bias exists, whether we want it to or not. We all have biases and use stereotypes every day, but we know that those terms evoke a very negative connotation, and so sometimes we shy away from talking about it. We know that stereotypes are simply a cognitive pattern. It's a very human thing. You can't prevent having stereotypes, but what you can do is recognize them and take steps to minimize the way that they impact the workplace. And the point here of the image is to point out the difference of stereotypes and biases. So take the red sign. It has no text on it, but we can all agree it means stop. You might have just noticed that it didn't have text on it. So this is a stereotype. It's just a widely held but fixed and simplified idea of an image. It's a cognitive shortcut. A bias is a little different. Perhaps you have a bias about what kind of person is driving the sports car that just blew the stop sign on the screen. It's a prejudgment in favor or against one thing compared to another. So a bias holds that piece of evaluation rather than an objective description. Which path is the better one to take, or what kind of person is in the sports car versus the cop car? That's based on a bias. So, more famously in the news a couple years ago in the tech world, something like men make better engineers because they're more rational or less emotional. That would be a bias. We can all agree that that's the kind of prejudice that's not based in data and one that's unfairly held against a group of people. Now, that's a pretty obvious bias that's consciously held and distributed. But for the most part in today's workplace, biases are much more unconscious and under the radar. We don't realize that we assume the youngest person in the room is the most junior, but we might base our behaviors and interactions from that assumption. So since these biases are unconscious, again, we're not talking about them or actively counteracting them. And so they're flying under the radar, and that makes them even more dangerous. If we're not able to recognize our own biases, we're often not going to recognize that there might be bias in past decisions that relate to data sources that we're depending on. So moving away from our example here on the screen, let's take a look at what this means for AI in the survey world. And part of this has to do with how AI and machine learning work. As we become more dependent on AI and machine learning within that, it's important to understand the way we're depending on data so that we can make conscious decisions about how we're training these systems and when we use them to essentially inform decisions. So very broadly, machine learning works well when we give a complex database with many kinds of data points. Essentially, we want to give it as many pieces to learn from as we can, and we want to give it a criterion or some sort of measure of success to predict. So as an example, recruiting systems might take in resume or other candidate information as inputs and a profile of what a successful person in that role looks like. Then the machine will learn from past decisions, such as who did well in that job, and then use the available data to create a profile or an algorithm that's going to identify cases that will fit that end goal. So the value and the possibilities here are that the machine learning can take in all of these disparate data points and identify relationships we don't know what to look for. In recruiting, machine learning can help us bust out of preconceived patterns and identify potential candidates that might not fit a typical or traditional profile that we would expect. So in this sense, the machine can get us a much better diversity of experience and even highlight our biases by displaying patterns that we normally ignore, whether that's conscious or not. The potential problem here is that we're training machines to learn based on past decisions that may have contained bias. our past decisions of success haven't always been inclusive. And so if we're feeding the machine biased data to learn from, it's going to give us biased models. If we provide limited data, it can only learn from those data points. And so ultimately, those decisions are going to be sub-optimized. A simple survey example, if we step away from recruiting, is if we have a survey that tells us all about engagement. It's going to tell us plenty about engagement, but if executives ask us about customer service or safety, we can't tell them what's going to be predictive of customer service or safety, or it'll be too many points past what we can predict. All we really know there is about engagement because we're sub-optimized. So, all of this said, our programs are getting better and better at making decisions that are consistent with the criterion we set. The technology is quite predictive, but it's dependent on the quality of the criterion. The programs getting more consistent doesn't mean the outcomes or the decisions themselves are better. A lot of us on the phone talk about garbage in, garbage out when it comes to predictive models. And what I'd like to add to that today is it's also bias in and bias out when it comes to these. And so I've got a couple of kind of non-survey examples here to look at as far as implications. At a first glance, the images on the screen might not look like they have a lot in common, but they're both examples of bias in artificial intelligence systems. So starting on the left, a lot of you might be familiar with Tay, otherwise known as a racist chatbot. And I'm not picking on Microsoft here. This was a huge experiment that they created and really learned a lot from. And the point was to see how this chatbot would interact on Twitter based on how real people interact with it. And it started out great. It was tweeting very neutral things, relevant to the way people were interacting with it. But within hours, Tay was tweeting racist and sexist posts based on what it learned from interactions with the public. And so the quick lesson here is that no matter how smart the machine is, garbage in, garbage out. Tay was very effective. It just learned from the inputs from the public on the internet. Shifting to the example on the right, we're actually moving into the danger of using some of these systems in recruiting and selection data. So this example is of a machine learning system that was looking for candidates with high potential for sales leadership roles. And what the analysts found was that the algorithm was selecting candidates who had been high school quarterbacks for these positions at a very high rate. And the algorithm itself wasn't wrong. The algorithm did what it was supposed to do. It found a relationship between people successful in that role in the past and participation in high school football. So then it selected future candidates that had high school football on their resume. Now, none of this is because high school quarterback experience leads to sales performance, but there was probably some underlying variable of goal orientation or leadership. But what happened is that the algorithm did its job, and it limited a whole lot of other candidates who were probably just as goal-oriented and could have been just as successful, but it's excluding anyone who wasn't a high school quarterback. So, any women, any people who didn't play the sport, or simply anyone who didn't put it on their resume. So in this way, the algorithm was as smart as it could be, but gave very biased data. And if we were to use that algorithm on its face value, the bias is learned and it's continually passed on, and we would continue to see an underrepresentation of women in sales leadership. So the lesson here is that the systems learn from the past. We all know that the past involves conscious and unconscious bias and discrimination. So if we ask our machine to learn from data about past success, and we use the same data we've looked at in the past, the machine's going to do its job. But it'll replicate a picture only of past success, which has not always been inclusive of everyone who can be successful. So if we aren't careful, it's easy to step back, abdicate responsibility, and say, this is a high power algorithm, we're gonna let it do its job, but that's what'll allow systemic discrimination to continue under the radar. So part of the challenge moving forward is how to include data that looks not just at where we've been and how we've been successful in the past, but look forward to what's important to help us guide into where we're going and who we want to see in these roles in the future. So if we take a quick pause, I think I have all of your attention that there are some dangers to this technology, and it's easy to become overwhelmed with, then how do we move forward here? I think it's important that we're all aware of this, because all of our organizations are moving in this direction, into using this kind of technology in order to make data-based decisions at scale, but it can certainly be done very well. If we're to use AI to add value and make better decisions, ones that promote inclusion and diversity, we just simply have to design them differently. So some general implications here. The first is to know your bias and the bias in your data. We're all human and we're all gonna have bias. That won't change. The key is not to deny this, but to become more aware of where our biases are, so that we can be conscious about the way we make decisions and what kind of data we choose to include or exclude in our systems, so that rather than allowing the machines to learn these biases, we design them in a way that counteracts or checks our biases. And this is hard. There's something called the Dunning effect, and that shows that the more competent you are, the more aware you are of your biases and potential shortcomings. The other side of that is, of course, people who are less competent or perhaps new at this are least aware of biases that might exist. And so some solutions there that you can build in include involving multiple data points and involving others. So not having single-threaded decisions of how you build these systems. Make sure that you can trace the decision-making patterns and have documents to check the process for bias. Often it's really great to involve people from across organizational functions in developing these models. The diversity of perspective and experience can help define the criterion for success in these models in a way that's more unique and strategic, rather than depending on the way things have been done before. So I'd encourage you to look outside of your initial group and see who else can think about how to measure success in these ways. Another point that we'll dive into more is to design systems that don't try to replicate human decisions just to make them faster, but design them to add value by doing what humans can't. Things like machine learning looking for relationships we didn't know to search for, that'll counteract our bias, and it'll work by including more data than we can usually handle with human systems. AI is incredibly valuable at taking complex, subjectively big data sets and drawing disparate relationships in the way humans can't. So in that way, AI can add scale and skill that human systems simply can't, and it'll look for patterns that you aren't able to search for on your own. So rather than looking for patterns that you expect to find, it's going to help you identify patterns you didn't know to look for. So step back and look at those patterns that the algorithm identifies that surprise you. Try to understand the patterns that you didn't expect. This is certainly a way it can add. And so the point here is, if we use systems to search beyond our expected patterns, we can use technology to expand our reach and show us what key points we've neglected in the past. One way to do that is not to look at data just about where we've been, but look at where we're going in terms of business goals, financial, operational, and values-based. For models to be useful in guiding future decisions, think about those elements of your strategic direction. In other words, when you're thinking about your criterion, don't be afraid to look outside of your HR data. And that takes us to some survey-specific kinds of advice. First piece is matching the purpose to the solution. The shiniest new product isn't always going to be the best. It won't always serve your strategic purpose. So think about what ultimately will give you the insight to drive action from your survey. And if the tool doesn't help you with that, even if you could do some fun analysis, keep looking. Second point is to maximize the use of data and to use AI to do what you can't. Spoke about that a minute ago, but I've got an example of a colleague I was talking to who was really excited to use machine learning for drivers. And he said it wasn't working that great. He had to go through manually and change so many things. And it begged the question of, why are you using that system rather than running drivers the old-fashioned way? If he had 50 business units and needed something done at scale, it might have made sense. But to use the system to run drivers for an company overall and to mess with it the way he had to made sense. So my advice here is, again, to do the opposite. If there's something you do well and it's working for you, keep doing it. Look for opportunities for ways to integrate data sources in a way that's too complex or time consuming for you to do. Often that's integrating different types of variables or different kinds of data sources that, again, the machine is going to add that skill and scale. And in this way, AI will enhance your impact by expanding rather than replicating your reach. And the third point here with employee research specifically is your stuff has to make sense. The use of the algorithmic solutions should still make sense to your stakeholders. You can't just build models and hand them off because there's statistical power. That works for customer clicks, but not when you're talking about employees. If you can't easily explain the model and implications to a leader, don't use it. A common example is around age and tenure. Often age comes up as a more potent predictor of opinions or outcomes, but it's illegal to act on people differently because of their age. However, tenure certainly makes a lot more sense. People need different things at different parts of the organizational life cycle. So that's one area where that human touch is really important, and you have to step back and work with the model. So, wrapping these together, I'll show you a couple of survey examples we've got here, how we use AI in some of our products. The first is called the OV Voice. This is a reporting system that helps users prioritize comments. So often an analysis problem that people run into is having piles and piles of unstructured data. And so what this does is it provides a 0 to 100 score on how likely the comment is, and then it prioritizes for the user what they should look at first. So it makes things really actionable and digestible for the user. Another example here is our action planning wizard, along with our action planning algorithm that identifies for each manager, what should they really work on. So often an issue at the end of a survey is managers are stuck in getting started with their action plans. And so what this does is it makes things really digestible and nudges them into where they can have the most impact. And so here, with both of these, what the artificial intelligence adds is some skill in terms of, coding these relationships, and it adds a lot of scale. Of course, a human could do either the comment coding or the action planning with managers, but they're unlikely to be able to do it at a scale across an entire organization. So this is one area where it's really adding to the power of what our humans can do by applying it across the organization. So in order to leave you with a couple of things to evaluate the use of AI within your own programs, I would use this set of questions to evaluate whether adding artificial intelligence is a value add that's going to extend your reach. And the first thing to do is to start with that question of what you want the data to do. What's your goal? And then second is understanding how the machine works. What's going to happen to your data, and how is it drawing conclusions? The third piece, is the machine replicating a human process, or is it doing something new? Is this replicating what you do, or is it making it better? And the fourth piece is, does it make sense? Will the insight from the machine inform practical human decisions that you can act on within your organization? So with that, that's going to conclude the content we've got for today. Unfortunately, we don't have time for questions, so if you, or to answer the questions live on the webinar, but if you do type them in, I'll follow up with you on the side. You'll also receive a survey as you leave the webinar. Please do fill out that survey. That feedback is really important to us as we shape out our other webinars. And you can also leave questions for us to address in that survey. So I look forward to following up with all of you on that. I'd also encourage all of you to check out our next session. It's called Framing Your Survey, Tactics to Get Executives Excited. So if you haven't had a chance, take a moment to go ahead and register for that one. And I'd also like to call your attention to a couple of services OV is offering through the COVID challenges we're all facing. One thing we're offering is an employee well-being and business resilience pulse survey. This is a free pulse that we're offering to organizations. It's available in 13 languages, and it includes administration and reporting, including benchmarks reports. We've already had 35,000 employees across the globe complete this survey, so I know there will be some really important findings, and we'd certainly like to share that with all of you. If you're interested in that pulse, please go to our website, orgvitality.com, and it's right there on the home page. So with that, I'd like to close out. Again, thank you all for coming, and I'll be following up with you shortly. Look forward to seeing you at the rest of the conference. Thank you.